Hello students, our next topic is gradient of a function. So consider a function t which depends on three coordinates x, y and z. This t is a scalar function. Okay. In the previous topic we have studied a function f which is dependent on x. So we have found out what is df. df is equal to the derivative df by dx into dx. So we have found out this is the slope of the curve f versus x. So this is the derivative since f is varying with x. Now if we have a function t such that it varies with x, y and z. So what will be the value of dt? So dt will be equal to the variation of t with along x direction. So we write it as dou t by dou x, which is called the partial derivative. So what is the variation of t along x direction? This into dx plus dou t by dou y into dy plus dou t by dou z into dz. So this is nothing but the variation of t when we move x by a small distance and y by a small distance or z by a small distance. So you get this is the differential of a scalar function t with respect to x, y and z. So this derivative dt is equal to dou t by dou x into dx plus dou t by dou y into dy plus dou t by dou z into dz. Okay. Now we split this term dt into two forms. You take this term as a dot product. So you can find dou t by dou x into x cap plus dou t by dou y into y cap plus dou t by dou z into z cap plus this dx x plus this dyyy plus dzz. So this is the small element of x, y and z along the corresponding directions x, y and z. So this is the small length element. This can be treated as the small length element when the function changes to dt. Now look at this term in brackets. This term is similar to a vector. So what is this dou t by dou x? It's a scalar factor along this direction. So this is similar to a vector. And this term in the bracket is called del t, or I will write it here, del t, which is called the gradient of the function. It is called the gradient of a scalar function t. This is equal to dou t by dou x into x plus dou t by dou y into y plus dou t by dou z into z. So this is a new function we are trying to find out. This is called the gradient of a function. Gradient of a, you remember, this is a scalar function. Okay. So since t is scalar, but delta t, the quantity gradient, is a vector quantity. So though this t is scalar, del t or the gradient of t is a vector quantity. Okay. So this is written over here. So del t is equivalent to dou t by dou xx plus dou t by dou yy plus dou t by dou zz, which is called the gradient of t. This is new to us. So try to remember the equation for delta t. Del t. Delta t is a vector quantity with 3 components. Okay. Now what is this gradient? What does this gradient means? Or what is the geometrical interpretation? Or what is the physical meaning? What this quantity represents? Delta t or the gradient. So we try to find out dt is equal to delta t dot dl. Del t dot dl. So since this is a dot product, we can expand it as, what is dot product equation? Is a dot b. This is equal to magnitude of a into magnitude of b cos theta, right? So accordingly we write it as magnitude of delta t, magnitude of dl cos theta. So what is this delta t? The magnitude of delta t, what is the magnitude of delta t and what is the direction of delta t? The first one says about the direction. The gradient of delta t, since it is a vector, it has some direction. So delta t points in the direction of maximum increase of the function. Since t has 3 components x, y and z, in what direction this t changes by an amount dt for which this has a maximum value, right? So that direction is represented by our gradient delta t direction. So delta t points in the direction of maximum increase of the function t. Okay, now what is the magnitude represents? The magnitude of delta t gives the slope or the rate of increase along this maximal direction, or it is called the slope. Delta t gives the slope along this maximum direction. Since the direction is along its maximum increase, in that direction the magnitude gives the slope or the rate of increase along this direction. This is termed as gradient of delta t. So delta t is called, the representation is like this. Delta t is equal to dou t by dou x into x cap plus dou t by dou y into y cap plus dou t by dou z into z cap, and this direction, the direction of delta t is along the direction of maximum increase of the function. The second point is that the magnitude of delta t gives the slope along this maximal direction. These are the 2 points of gradient.